Listen, handshaking theorem. The statement of the handshaking theorem is sum of degree of a connected graph, connected undirected graph is twice the number of edges. Okay, so connected graph, we should know solution. Connected graph, this is a proof, we have to write as a proof. This is a connected example for the connected graph. Vertex V1, V2, V3, V4. In university exam, you should not draw the diagram to prove the theorem. It's for your understanding, I am drawing the diagram. That is a graph E1, E2, E3, E4. Vertex 1, vertex 2, vertex 3, vertex 4. Edge 1, edge 2, edge 3, edge 4. Connected graph means it should have the path from V1 to any vertices. V1, V2, V3. So from V1 we can reach any points. This is called the connected graph. Not connected means this is not connected because one vertices comes alone. There is no path between any vertex to this vertices. Okay, this is not connected. This is a connected graph. So in our theorem they have given it is a connected graph. Okay, so we have to take connected graph. Theorem says that degree of, that is sum of degree of connected graphs is twice the number of edges. So here we have to take, let E is a edge set of G. Simply G denote the graph. E represent the edge set. Here 4 edges are there. We should not take this as into the theorem because it is for your understanding only. Let E is a edge set of G and V is a vertex set of G. Vertex set of G. Here degree, we have to take the degrees. Sum of degrees of connected graphs. Each and every edges having the end vertex. Okay, each and every edges having end vertex. So each and every edges contribute sum of 2 vertices. Is it not? What is E4? E4 contribute how many vertex? 2 end vertices. E1 contributes 2 vertices. Like that U2 contributes 2 vertices. So every edges contribute 2 vertices. So sum of 2 vertex, so sum of edges contributes 2 vertices. Sum of each vertices or each edges contributes 2 vertices. 2 vertices. So in generally we can write sum of the edges E1 plus E2 plus etc. En. Sum of the edges. Okay. Sum of the edges contribute how many vertices? How many vertices? 2 vertices. How many vertices? 2 vertices. In connected graph, what is the maximum degree of the vertices? V4, here 2, but some problem 3, like that it will change. But in generally, the degree of the vertices should be less than or equal to n minus 1. N represent the number of edges. Here n represent the number of the vertices. N represent the number of the vertices. N represent number of vertices. N represent the number of vertices. Listen, degree of V1 plus degree of V2 plus etc. degree of Vn equal to, we will get twice the edges. Twice the edges. Listen here. What is the degree of V1? 2. Degree of V2? 2. Degree of V3? 2. Degree of V4? 2. So sum of the degree should be equal to twice the edges. Twice the edges. Because how many edges are there? 1, 2, 3, 4 edges. So what is 2 into E? 4. According to this graph, 4. Okay, sorry. 2 into E. E is a 4. So we will get 8. We will get 8. What is the sum of the degrees? V1 contribute 2 degree. V2 contribute 2 degree. V3 contribute 2 degree. V4 contribute 2 degree. So what is the sum of? So 2 into 2E equal to sum of the degrees. So it represents like that. Okay, it represents like that. So generally we have to write sum I equal to 1 to n, degree of Vi equal to 2 times edges. 2 times edges. So sum of all the connector graph, in sum of all the connector graph, sum of degree of the edges should be equal to 2 times degree of E. Sorry, 2 times edge. 2 times its edge. E represent the number of edges. Okay, E represent the number of edges. This is the handshaking theorem. You have to write the wordings. In book they have given up in para-rap model, but I explained through the example. You should not write this example in university examination, but you have to write these things. If I didn't draw this diagram, you won't understand this concept. Okay, with the help of this diagram you can understand the concept. Degree of sum of degree of vertex is equal to 2 times edge set. 2 times edges. It's for the connected graph. If it is not connected, we can't use handshaking theorem. Okay, it's applicable for only the connected graph. Okay, right. Still, this is the final step.